Welcome. So here we have a situation where it says express this vector, the one in the diagram, in IJK vector notation. And here we're given the magnitude of the vector and also its angular direction with respect to the positive x-axis. So I need to be able to visualize this and be able to write it down using IJKs. Um, I'm only working in two dimensions here. I have my x-axis, and my y-axis, and I'm going to draw this like that. This is 25 degrees. And what I want to do is I want to work out what my x component is, I want to work out what my y component is, and I want to work out what my z component is, and put these things then in IJK notation. Let's begin by looking at the x component. As always, I project from the tip of my arrow down to the axis. I imagine it's a wooden arrow and the light is above the x-axis. And I ask myself, how long would that shadow be? And of course, this is 7 meters. So this would be 7 cosine 25 meters, and it's going to be a positive because it's going in the positive direction. I can imagine my y-axis, and again I imagine the light to the right hand side now shining the shadow of the wooden stick on a vertical wall, and I see that, oh yes, there's a shadow there, and how long is that shadow? And it would be plus 7 sine 25 degrees. And it turns out there's no tendency to lean into the z-axis. Remember that we have our x-axis, we have our y-axis, and then we have our z-axis. And we deal with the x's by talking about i's, and we deal with the y-axis by talking about j, and we deal with the z-axis by talking about k. Because there's no tendency, there's no component of this original vector coming into or going out of the page. There's no z-axis component. But we're still going to write it down. And we say, well, what do we have? Well, we have plus 7 cosine 25 I. I'm going to put that in lots of parentheses and brackets. Plus, and now I'm going to look here, I'm going to say, oh, we have plus 7 sine 25j, because this is my j component, plus 0k, because there's no z-axis component, and this is a displacement, so that whole thing is in meters. So I need to get my calculator out, and I can say, let's call this vector r. So I can say vector r is equal to, I just get my calculator and I'm just going to simply say 7 cosine 25, and that's going to equal 6.3, so this would be plus 6.3 I. And then we add on to that our next component, which is 7 sine 25, and that's going to be 2.958, call it 3.0. So that will be plus 3.0j. Oops, there. And then let's add on our z component, and we know that this is 0.0 ijk. And then we got to put the whole thing in units. So that would be meters. And people would simplify the writing of this to say R is equal to 6.3i plus 3.0j plus 0.0k. Put that in parentheses, meters. And if I look at the side, I have 6.3i plus 3.0j. So it looks like it's this guy there. So there we have it.